So today we're going to do chapter 1.2, which is using the completing the square method and the quadratic formula to solve quadratic equations. So 1.2, solving the quadratic equation using the completing the square method and using the quadratic formula. So let's begin by looking at completing the square method. This method, if we think about a quadratic equation, it's of the form ax squared plus bx plus c is equal to 0. What this method says is that we would, first we would need to have a equal to 1. So the coefficient of x squared must equal 1. And the second principle is that the constant term must be on the right hand side. So what we would have then, since a is equal to 1, we would have x squared plus bx is equal to that constant term, plus or minus that constant term. That constant term will be on the right hand side. And the principle is very straightforward. It says we put whatever sign we have here, plus or minus, take half of b, square the whole parenthesis, c, plus take b over 2 and square it and add it to the right hand side. So the way this works is that if I have, say, x squared plus 6x minus 27 is equal to 0, and I'm asked to solve this, the very first thing I would want to do is to add 27 to both sides to make sure that the constant term is on the right hand side. Now, here we go. We're going to put x, bring down the plus sign, take half of 6, which is 3, square, and then take 3 squared, which is 9, and add it to the right hand side. So this is x plus 3 squared is equal to 36. Using this square root property, we can say x plus 3 is equal to plus or minus the square root of 36. So x plus 3 is equal to plus or minus 6. And then if we took away 3 from both sides, we would have x is equal to negative 3 plus or minus 6. This gives two answers. X is equal to negative 3 plus 6, which is equal to 3. And x is equal to negative 3 minus 6, which is negative 9. So your two solutions to this problem, 3 and negative 9. More examples. X squared minus 6x minus 2 is equal to 0. So x squared minus 6x is equal to positive 2. x, take half of, bring down that negative sign and take half of 6, which is 3. Okay, so there's 6 divided by 2, which is 3. And then take that 3 and square it and add it to the right hand side. So 3 squared is 9, and add it to the right hand side, plus 9. So what we've got here is x minus 3 squared is equal to 11. So x minus 3 is equal to plus or minus the square root of 11. Take away 3 from both sides. X is equal to positive 3 plus or minus the square root of 11. So this has two solutions, 3 plus the square root of 11 and 3 minus the square root of 11. This is the way you'll be expected to type your answer into the MyMathLab homework, separated with a comma, and do not put the square root of 11 in a calculator. Just leave it as the square root of 11. Now, I told you that the coefficient of x squared must be equal to 1. So if it's not 1, we would have to work on making it 1. For example, I've got 2x squared plus 8x plus 2 is equal to 0. So taking away 2, first I noticed that I would have to divide everything by 2 to get that coefficient of x squared equal to 1. So this equation becomes x squared plus 4x plus 1 equal to 0. Taking away 1 from both sides, we have x squared plus 4x is equal to negative 1. And here we employ the completing the square technique. X, take half of 4, which is 2, and then square 2 and add it to the right hand side. So this is x plus 2 squared is equal to 2 twos are 4 minus 1 is positive 3. So we use the square root property. This is x plus 2 is equal to plus or minus the square root of 3. And then take away 2 from both sides. We get x is equal to negative 2 plus or minus the square root of 3. So your two solutions, negative 2 plus the square root of 3 and negative 2 minus the square root of 3. Now, let us take this a step further and consider some examples involving, say, problems with fractions. If I were asked to solve x squared minus 1/2 x minus 3 over 16 is equal to 0. So remember, the first principle is that we move the constant term to the right hand side. So this is x squared minus half x is equal to positive 3 over 16. And we open our parenthesis. X, bring down the negative sign, squared 3 over 16. And then we take half of a half. So half divided by 2 is equal to 1/4. Write it in here. And then 1/4 squared is 1/16. So we add 1/16 to both sides. So we're going to work on simplifying this. This is x minus 1/4 squared is equal to 4/16. 3/16 plus 1/16 is 4/16. And next we use the square root property. X minus 1/4 is equal to plus or minus the square root of 4/16. So the square root of 4/16 is the square root of 4 divided by the square root of 16, which is 1/4. Sorry, 2/4. 2/4, which is 1/2. So now we've got x minus 1/4 equals to plus or minus half. Add 1/4 to both sides. Gives us x is equal to 1/4 plus or minus 1/2. So x is equal to 1/4 plus 1/2, which is equal to 3/4, and x is equal to 1/4 minus 1/2, which is negative 1/4. So your two solutions, 3/4 and negative 1/4. If you're not sure about fractions, you can always use your calculator to do fractions. For example, if I wanted to add 1/4 and 1/2, I would press alpha, y equals, and enter the fraction. 1/2 plus alpha, y equal 1/4, and that would give me my answer. Alternatively, you can say we wanted to add negative half plus 1/4. You can simply type open parenthesis negative 1 divided by 2 close parenthesis. Make sure you separate the fractions by parenthesis, plus 1 divided by 4. Then press math, fraction, answer. So those are two separate ways that you can get your answer for these. In case you have trouble with fractions, we're not in this class to learn how to do fractions. Hopefully you know how to manipulate fractions already. Okay? Okay, so I'm going to do one more example using completing the square. Here we go. This is solving 3x squared plus x minus half is equal to 0. So 3x squared plus x is equal to positive half. Then if we divide everything by 3, because we have to clear we have to clear the 3 from the coefficient and make it into 1. So we now have x squared plus 1 over 3x, and half divided by 3, half divided by 3 is equal to 1 over 6. So this is 1 over 6. Now the problem is in the format where we can employ the completing the square method. X squared, bring down the plus sign, half of 1/3, half of 1/3 is 1 over 6, and then 1 over 6 squared is 1 over 36. So this is 1 over 6, and this is 1 over 6 plus 1 over 36. Remember that part goes in the right hand side, and the half part goes into the parenthesis. So we've got x plus 1 over 6 1 over 6 plus 1 over 36 is 7 over 36. Okay, and I showed you how to use your calculator to add that. So this is really 6 over 36 plus 1 over 36, which is 7 over 36. So x plus 1 over 6 is equal to plus or minus the square root of 7 over 36. Now, consider the square root of 7 over 36 is the square root of 7 over the square root of 36, which is the square root of 7 over 6. So this is x plus 1 over 6 is equal to plus or minus the square root of 7 over 6. Next, we need to take away 1 over 6 from both sides. Okay, that isolates x by itself on the left hand side. This gives x is equal to negative 1 over 6 plus or minus the square root of 7 over 6. Since the denominators are the same, we have two separate answers. X is equal to negative 1 plus the square root of 7 over 6, and negative 1 minus the square root of 7 over 6. Again, this is the format that you're going to be typing your answers in to my MyMATLAB homework. So pay attention to how you type that in. You do not put the square root of 7 into a calculator and get a numerical answer for that, unless it's an exact square root. All right, so now we're going to look at using the quadratic formula. And I know that this is not your first experience using the quadratic formula. It's just building on what you know already. Recall that if we have a quadratic equation, ax squared plus bx plus c equals to 0, then the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. and this is known as the quadratic formula. The quadratic formula can be used to solve any type of quadratic equation, including problems that are factorable or problems that we did in the previous method. In other words, the ones that we did by completing the square, we could also solve them using the quadratic formula as well. So remember, we're kicking this up a notch because you guys are doing a college algebra course. So let's first look at the quadratic equation and how we're going to solve it. We have half x squared minus 1 over 8x minus 7 over 4 equals to 0. So we don't want to put fractions into the quadratic formula. That would create a mess. So our first goal here is to clear the fractions, and we would clear the fractions by multiplying by the LCD, which in this case is 8. So everything will get multiplied by 8. Right? So 8, 8, 8, 8. So half of 8 is 4x squared. 8 into 8 is 1. So this is negative x. And 4 into 8 is 2. 2 times 7 is 14. Is equal to 0. Okay? Again, to do that, 2 into 8 is 4. 8 cancels out with 8 one time, and then 4 into 8 is 2. So now we have the setup for the quadratic formula. We can also do this by completing the square, by dividing everything by 4 and using the completing the square method that we discussed earlier. Here we would go ahead and identify A is equal to 4, B is equal to negative 1, and C is equal to negative 14. Write your formula down, minus B plus or minus B squared minus 4AC square root over 2A. And then take one step to substitute everything. So this is minus negative 1 plus or minus negative 1 squared minus 4 times 4 times negative 14 over 2 times 4. Take that one whole step to simplify to make your substitution. So negative times negative is positive 1 plus or minus 1 minus 4 times 4 times 14 is 224 positive over 8. Notice that when we squared negative 1, we got positive 1 here. Be careful with that, okay? So this yields 1 plus or minus the square root of 225 over 8, which is 1 plus or minus the square root of 225 is exactly 15 over 8. So we've got two solutions, 1 plus 15 over 8, which is 2, and 1 minus 15 over 8, which is negative 14 over 8, which is negative 7 over 4. So your two answers, 2 and negative 7 over 4. Recall that using the quadratic formula, signs will be your challenge. Pay attention to multiplying negative and positive signs or squaring negative and positive numbers and see what happens. Okay. All right, here's another example. And by the way, the examples that I'm doing are the homework questions. So if you follow these, you're going to be able to do your homework. So this does not look like a quadratic equation, but we want to solve for x. So we're going to distribute first to give 3x squared plus 6x is equal to 2. So 3x squared plus 6x minus 2 is equal to 0. A is equal to 3, B is equal to 6, and C is equal to negative 2. Always write your formula first. X is equal to minus B plus or minus the square root of B squared minus 4AC over 2A. And then take one whole step to make your substitution. So this is negative 6 plus or minus 6 squared minus 4 times 3 times negative 2. Let's fix that right there. All over 2 times 3. So we've got negative 6 plus or minus 36. This is 4 threes are 12, 12 twos are 24 positive over 6. So this is minus 6 plus or minus the square root of 60 over 6. Now you're going to have to simplify this radical. Okay, so this is not something that you will want to put into the calculator. The calculator is not going to help you. We want to simplify the radical by taking out the largest perfect square in there, which is 2 squared or 4. So this is negative 6 plus or minus the square root of 4 is equal to 2. So it's 2 square root 15 over 6. And then notice that in the numerator, 2 is a common factor. Two is a common factor. And then we're able to go ahead here, right here, and reduce that. So this becomes negative 3 plus or minus the square root of 15 over 3. So my two solutions, negative 3 plus the square root of 15 over 3, and negative 3 minus the square root of 15 over 3. Make sure that you're simplifying the radical when you get to this stage right here. Make sure that you are working on simplifying that radical. Don't type in the answer as negative 6 plus or minus square root of 60 over 6. All right, one final example for the quadratic formula. So here I have 4 minus 1 over x minus 2 over x squared is equal to 0. So in order to clear the fractions here, the 1 over x and 2 over x squared, we have to multiply everything by x squared. So 4 times x squared minus 1 over x times x squared minus 2 over x squared times x squared is equal to 0 times x squared. This gives us 4x squared. Then we have x squared divided by x, which is x. And then x squared cancels with x squared to give minus 2 is equal to 0. And all of a sudden, this equation does not look so scary. So a is equal to 4, b is equal to -1, and c is equal to -2. X is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2 over 8. So take one whole step to do your substitution. This is minus -1 plus or minus -1 squared minus 4 times 4 times -2 over 2 times 4. So positive 1 plus or minus 1, -4 times 4 minus 2 is positive 32 square root over 8. So 1 plus or minus square root of 33 over 8. 33 has no perfect squares, so we don't have to worry about simplifying that radical. We write our two answers and problem is solved. Okay? All right, important note. All examples are similar to your homework problems. Okay? All examples are similar to your homework problems. So you can actually do your homework while you're looking at the examples that I'm solving.